Hello students, in this video we'll be solving a few problems from the chapter Light, Reflection and Refraction. Our first problem is the radius of curvature of a convex mirror is 25 meters. Find the focal length of the mirror. So the formula for this, to find out the radius of curvature of convex mirror, how do we find out? First of all, the formula is focal length is r upon 2, because focal length is half of the radius of curvature. But here we don't need to find out focal length. Here we need to find out focal length and the radius of curvature is given. Okay, so we just write down what is the radius of curvature, that is r is equal to 25 meters. So f will be equal to 25 upon 2, and that would be 12.5 meters. So that is our focal length. That is the answer to the first question. Next question is, find the focal length of a lens of power 2D. Remember the units of power, it is D or diopt. So in this case the power is given and we need to find the focal length. What is the formula for finding the power? It is P is equal to 1 upon F, provided the focal length is given in meters. However, in this case we are not given the focal length, we are given the power and we need to find the focal length. So in that case all we need to do is take focal length here, bring the power down here. So this will be F is equal to 1 upon P, and P is given as 2, so that would be 0.5 meters. By default it is always meters, so the focal length of this lens would be 0.5 meters, where the power is given equal to 2D. Next question, find the power of a convex lens of focal length 50 centimeters. In the previous case the power was given, we had to find the focal length. Here the focal length is given, we need to find the power. However, we need to note one thing down over here. The focal length is not given in meters but it is given in centimeters. So we use a different formula. Usually the formula is P is equal to 1 upon F. But whenever there is centimeters, to convert it into meters, we multiply this by 100 and then this becomes 100 upon F. The formula just changes to P is equal to 1 upon F to P is equal to 100 upon F. Then it will be written in meters. The final answer will be, the units of that answer will be in meters. So write down F is equal to 50 centimeters. So P formula we use is P is equal to 100 upon F and 100 upon 50. So we don't change the 50, we write the 50 the way it is. So 51s are 50, 52s are 100, and that would give us the power equal to 2, and the units of power is D and not meters. Okay, so we remember we can only get to this answer once we convert it from centimeters to meters, and to do that we have a direct formula where we just write P equal to 100 upon F. And do not forget that the unit of power is diopt and not meter or centimeter or kilos and something. Okay. Next question says, the focal length of a convex mirror is 30 centimeters. Calculate its radius of curvature. So in the first problem that we solved, in that we had to find out the focal length where the radius of curvature is given. Here we need to find out the radius of curvature where the focal length is given as 30 centimeters. So the formula is F is equal to R upon 2, where F is given, which is equal to 30, and R needs to be found out. So in this case we multiply 2 into 30 and we will get our radius of curvature, which is 30 into 2 is 60 centimeters, because F is 30 centimeters, so the units will be centimeters. So the radius of curvature for that particular convex mirror is 60 centimeters. The next problem says, the height of an object is plus 5 centimeters and the magnification of the image produced by a convex mirror is 0.6 centimeters. Find the height of the image. Okay, you notice how it is given as plus 5 centimeters, plus 0.6 centimeters. That shows you that signs are very important in this particular problem. So you need to take note of that. So you may have a negative sign as well in between. So we need to see over here what type of a problem this is. This is a mirror problem, which means we have a convex mirror. So convex mirrors are how? Convex mirrors are this way, with the principal axis here, and the object will always be on this side, but the image will be formed here, okay, and it will always be virtual and erect. So remember, in this case the height of both of them will be positive, the object height and the image height. I'll put this object height as u and v, or in other case it actually height of the image is h dash and h. That's how we note down the heights of, or symbolize or denote the height of the object and that of the image. Over here, in case of convex mirrors, we get what type of images? We get virtual and we get erect images. And if it is erect, that means the height of the image has got to be positive. So that is why the plus signs are very, very important to note over here. So what is the formula for magnification? It is m equal, in terms of height, it is h dash upon h, which is height of the image upon height of object, okay. And height of magnification is given as 0.6. there is no need to write now plus, it is understood. Only when it is negative we put the sign over there. Height of the image is given, no, we need to find that out, so that would be h dash, and height of the object is given as 5 centimeters. So if we multiply 5 into 0.6, we should get the height of the image. So that would be 5 into 0.6, that would be h dash would be equal to 3.0 centimeters. That means the height of the image is equal to 3 centimeters. It is, if m is greater than 1, then it is magnified. If m is equal to 1, then the image size is same as that of the object. But if m is less than 1, then it is small or diminished based on how small the value is. So here the value is quite small, so which actually tends to tell you that the height of the image formed is not greater than that of the object, but is small, okay, compared to the height of the object. So slightly smaller. This is 5 centimeters, the height of the object is 5 centimeters, but height of the image is 3 centimeters. So remember, this is how we come to the conclusion whether the image has been magnified or not. So you may get application questions based on this problem as well, if in case the examiner feels like asking an additional question based on this solution, okay. Our next problem is, an object is placed at a distance of 12 centimeters from a convex lens. If a real image is formed at a distance of 24 centimeters from the lens, calculate the magnification. Once again, the positive and negative signs will come into play over here. What we need to see is, what are we talking about? We are talking about a convex lens. So how is a convex lens? The convex lens is this way. Now we said an object is placed at a distance of 12 centimeters from a convex lens, so which means it is actually placed, this would be your optical center somewhere over here, that would be O, and your object would be placed somewhere out here, that would be from here to here would be 12 centimeters. Now we are said, if a real image is formed at a distance of 24 centimeters from the lens, so which means the distance will be somewhere over here, and it would be a real and inverted image, which means it is falling on the right hand side, which means since we are talking about distances, this distance will be positive because it is on the right hand side of the x-axis, whereas this distance will be on the negative side and this will be negative. So which means how do we denote the distance of objects and images. The object distance is given as u, and image distance is given by v. Okay, so u will be minus 12 centimeters because it is on the left hand side and it's on the negative x-axis, whereas the distance of the image will be positive 24 centimeters, and we need to find out the magnification. So all we need to do is find out the magnification, which is equal to v upon u, okay, where u is negative, but we'll write that later on. So this is nothing but distance of image from O, that is optical center, and this would be distance of object from O. If we calculate, that would be V is 24 upon 12, that would be minus 12. So 12 on the 12, 12 to the 24, which means we get minus 2. That would be the magnification of this particular object. Okay, the object, that means, in other words, since it is minus 2, it's what is it? It is m is less than 1, which means that this particular object appears diminished. And units don't remain over here, because if you notice, this is 24 centimeters and this would also be at minus 12 centimeters. So centimeter cancel, and we are just left with the magnification of minus 2. So it has no units. Next question says, when a 2 centimeter high slide is placed at a distance of 16 centimeters from the lens, the image is formed on a wall at a distance of 1.6 meters. What is the height of the image? Justify your answer. Once again, we look at what we are dealing with. We are dealing with a lens. Okay, we are not told whether it's a convex lens or a concave lens, but we are told something else. He said that the image is formed on a wall. So what type of images do form on a wall? See, on a wall we form real and inverted images. Okay, we don't form virtual and erect images on a wall, and that is why you cannot see yourself on a wall. Okay, but something from a projector can be seen on a wall. So that is why we have real and inverted images. So in which cases do we have real and inverted images in terms of lenses? It will be in case of a convex lens. Okay, it will be in terms of a convex lens. In terms of concave lenses, we get virtual and erect images. So we have said 2 centimeter high slide is placed at a distance of 16 centimeter from the lens, which means that we have if we take this as the principal axis, we have a 2 centimeter slide which is placed at a distance of from here, it would be, this would be the optical center, 16 centimeters here, 2 centimeters of this height. The image is formed on a wall at a distance of when a slide 2 centimeters is placed at a distance of, the image is formed on a wall at a distance of 1.6 meters. So it is formed at a distance of 1.6 meters. We need to find the height of the image. So we say real and inverted, that means it will be something over here that would be formed. So we need to establish the relationships in order to find out. So let's put down whatever we have been given. We are given the height of the object. We are given the height of the object. We given the height of the object. Height of the object is given as h, and that is 2 centimeters. Then we are not given the height of the image. That is what we need to find out. So height of image, that would be h dash. We need to find that out. We are given distance of the object from the lens. So distance of object, that would be not v, but distance of object will be u, and that is 16 centimeters. So that would be minus 16 centimeters. And we are given the distance of image would be v, and that would be 1.6, and that would be positive 1.6, and that is 1.6 meters over here. If we notice over here, the height of the object is given in centimeters, distance of the object is given in centimeters, but distance of the image, okay, is given in meters. So we need to convert this into centimeters. If we recall how we get power, it is this way: P is equal to 1 upon F, but this is in meters when the focal length is in meters. But if the focal length is given in centimeters, then how we need to convert it to meters. So for that, what we do is we multiply this with 100. Okay, actually what really happens here is that 1 meter is actually equal to 100 centimeters. Okay, 1 meter is equal to 100 centimeters. So in this case it becomes the reverse. What happens here is 1 centimeter becomes 0.01 meters. So when we have 1 upon F and we put this as, since we focal length is in denominator, from centimeters, when we convert it to meters, we actually multiply it with 0.01. Now we don't want the decimal, so what we do is we multiply on top and below with 100, and when we do that, 100 multiplied with this becomes 1, and 100 multiplied by 1 remains as 100, and this will remain the way it is, and that is why we have 100 upon F. Finally we write power is equal to 100 upon F. I hope you get this. Okay, 1 meter is equal to 100 centimeters. Look at this conversion, and 1 centimeters is equal to 0.01 meter, and that is why we have P is equal to 1 upon F, which is given as 1 upon F into 100. Okay, now similarly we need to change this thing. Okay, so we are given as meters, we need to convert it into 100 meters. So we know 1 meter is equal to 100 centimeters. So 1.6 will be multiplied into 100 to give us 160 centimeters. How do we do that without multiplication? Whenever there is a decimal point and we multiply it with additional zeros, so look at the number of zeros, 1 and 2, so it will go 1 place 2, so that means 1.6 can be written as 1.600. When we multiply this by 100, what happens is 100 is how many zeros? 1 and 2, so it's 1, 2, and we have 160.0, which we can write it as just 160. This is just the zeros after the decimal point are not so relevant, and I can keep adding zeros. This is just to show you how do we get. And now you can do the same thing by doing the long multiplication method, that you multiply 100 into 1.6 and you will get the same answer. But I hope you have understood how we have got 160 centimeters from 1.6 meters using this conversion. Okay, this conversion also holds true when finding power of the lens when the focal length is given in centimeters. Now coming to the real problem, we have got this. Now we need to establish a relationship. Now we know, if we recall, magnification is given as V upon U, and it is also given as H dash upon H, which means we can write V upon U equal to H dash upon H. Fine. Now if we substitute the values in this particular equation, we should be able to get the height of the image. Remember, the height of the image is H dash. So height of the object is given. So we'll find out what is V. V is 160, U is minus 16, so I'll put this in brackets, okay, equal to h dash, which we need to find out, that is the height of the image. Height of the object is given as 2. Fine. Now 16 ones are 16, 16 tens are 160, and 2 will go and multiply with 10, and finally we get h dash equal to minus 20 centimeters. Okay, because we have converted everything into centimeters, so we can write the height of the image as centimeters, and this is negative. Now the negative height of the image tells you that the image is inverted. Okay, the image that we get is inverted. So justify answer. Now to justify answer, we can easily say that since the image is formed on the right hand side of the optical center, hence the image that is formed is real and inverted, and such a image is usually formed with in case of a convex lens. Okay, there are lots of justifications that you can give, but this is the answer. And to know that, we need to know about this x and y axis. That is why it becomes important to know which side of the axis your image comes and which side of the axis the object is, the distance, the length of the distance of the image and the distance of the object, whether it is positive or negative. Okay. Our next problem says a 2 centimeter tall object is perpendicular to the principal axis of a convex lens of focal length 10 centimeters. The distance of the object from the lens is 15 centimeters. Find the image distance and the height of the image. Okay. Once again, it's a problem of convex lens which have a principal axis here, object is out here, image, since it is convex lens, it will be real and inverted, formed on the other side. We are given a distance from of the object from the lens is 15 centimeters, so it is 15 centimeters here. The focal length is given, some which will be over here, which will be somewhere around 10 centimeters, and the object is 2 centimeters tall. Now we need to find the distance of the image as well as the height of the image. Let's write down what we have given. We have been given first. So we are given 2 centimeter tall object. So that means we are given h is equal to 2 centimeters. We are given the focal length, which is 10 centimeters. Okay. Now the focal length will be negative. Why is it negative? Because the focal length will be the focal length won't be negative, it will be positive because it's formed on the other side, not here, it's actually going to form somewhere over here. Distance of the object from the lens 15 centimeters, so that is u is equal to 15 centimeters, and this will be negative. Find the image distance and the height of this. So we need to find h dash and we need to find as well as v. So how do we find from here? So if we remember lens formula, the lens formula says what? This is the mirror formula, and the lens formula is 1 upon f is equal to 1 upon v minus 1 upon u. See the difference between the mirror formula and lens formula. Okay, now we need to use this formula. Since we are talking about a lens, the lens formula needs to be used, because in this case we are given the focal length and we have been given the object distance, but we have not been given the distance of the image. So we need to make use of the lens formula in order to write it down. 1 upon f is equal to 1 upon v minus 1 upon u. We need to find out v. So I'll take 1 upon u on the left hand side, and that would become positive. So we have 1 upon v is equal to 1 upon f plus 1 upon u. So all I've done is actually taken 1 upon u on this side, but just written it in a way that 1 upon v comes on the left hand side. Okay, so 1 upon v is equal to 1 upon f plus 1 upon u. Now we write 1 upon v here F is given as 10 centimeters and U is minus 15. So we'll write this as minus 15 out here. Now what you need to do is we need to take the LCM between the two, and the LCM will come as 30. So this would be 3 over here plus 3 upon 30 plus this will become minus, since this minus sign is there, 2 upon 30. Since the denominators are the same, we can directly subtract 3 minus 2 upon 30. Continue over here. That would be 1 upon V equal to 3 minus 2 is 1 upon 30. Now we take the reciprocal and we'll get V is equal to 30 centimeters. So the distance of the image is 30 centimeters. Now that we have got that V, we can find out H dash using this formula. H dash upon H equal to V upon U. H dash we need to find out. H is 2, V is 30 and U is minus 15. So 15 ones are 15, 15 twos are 30. 2 into 2 gives us 4. So H dash equal to minus 4 centimeters because the negative sign over here. So this tells you that the height of the image is negative. And why is it negative? It is negative, that means it tells you that it is the height, the image is inverted, as I told you before, because convex lenses form real and inverted images. So all these problems have come in some exam papers. So please go through them. So if you've liked watching this video, please click the like button, share it with your friends and classmates, and please subscribe to the channel. Thank you for watching. See you in the next video.